welcome to Whose Fault Is It Anyway? I'm your host, Allie Belder, and today we will be deciding whose fault it was from an accident. We're bringing in a couple of physicists from Mr. Dett's 6th period physics class to tell you whose fault it was.
Based on our observations, we have determined that the SUV had hit the wagon. So, using our kinematic equations, we have determined that the braking was at negative 2 meters per second. The skid mark was at 2 meters, and we plugged it into the following kinematic equation, where final velocity squared is equal to initial velocity squared plus 2 times the acceleration and the displacement. When you plug it in, you eventually get down to 2.3 meters per second for the initial velocity.
Based on our observations from the accident, we know that the Subaru was at rest at a stop sign immediately prior to the collision. Using measurements and calculations, we were able to determine the initial velocity immediately after the accident. To do this, we used the kinematic equation. The final velocity squared equals the initial velocity squared plus 2 times acceleration times distance. Based on measurements and observations from the wreck, we know that the final velocity is 0 meters per second. So we plugged that into the equation. We also plugged in negative 3 meters per second squared, the acceleration of the Subaru with its brakes locked. We also plugged in 24 meters, which is the distance of the Subaru's skid marks. Then, doing simple algebra, we simplified the equation to the eventual conclusion that the initial velocity of the Subaru immediately after the collision was 12 meters per second.
Okay, so the total momentum of the collision is a combination of the 8,490 kilograms times meters per second of the Subaru plus the 24,000 kilograms times meters per second of the SUV, which makes a total of 32,490 kilograms times meters per second for the total system. And the initial momentum of the Subaru is 2,000 kilograms times 0 meters per second, which means that its total momentum is 0.
So according to the law of conservation of momentum, the total momentum for the initial should be the same as the total momentum for the final. So that's 32,490 kilograms per meter per second. And to find the initial velocity of the SUV, you have to divide that by 3,000 to get 10.83 meters per second.
Then using the same equation of momentum equals mass times velocity, you can find the final momentum of the Subaru. So you plug in the 2,000 kilograms for the mass and your 12 meters per second to get a final momentum of 24,000 kilograms times meters per second.
As one of the investigators, our job was to find whether the accident was either an elastic or inelastic accident. We found that it was an inelastic accident due to the fact that both cars stuck together after the collision. If it was elastic, then they would both have rebounded off each other and have gone into opposite directions.
Okay, kinetic energy is the ability of one object to be able to move another one and can be described as being qualitative and quantitative. Investigators often use qualitative and quantitative data to organize and help recreate the happenings of an accident. Qualitative or kinetic energy is both scalar and can be determined using the equation kinetic energy equals 1/2 the mass times velocity squared. Kinetic energy is both quantitative and qualitative because you have to understand the physics concepts behind the calculations and equations.